Okay, all pre-calculus fans, today we're looking at what's called Descartes' rule of signs. Okay, Descartes was not only a philosopher, but he was also a mathematician. So you can, all right, so, now, very first thing we talk about when we talk about Descartes' rule of signs is does that mean? Well, he came up with these theories about the potential number of positive real roots and the potential number of negative real roots. And his thing was not only, his thing was simply all we do was look at the sign changes. We count the sign changes, okay? So in order to find the potential number of positive real roots, all we have to do is count sign changes. And so what that literally means, how many times does this thing go from positive to negative? Okay, that's it. Or negative to positive. So notice this starts positive. There's no sign in front, it's positive. It starts positive, and then it changes to a negative. Then it stays negative, and then it changes again, and then it changes one more time. So that was 3 times I said the word change. So starts positive, changes, stays, changes, changes. So this says it has the potential to have 3 positive real roots. Now remember, real could be, square root of 5 is a real number. Okay? And now, in order for us to figure out, so this is the maximum number of positive roots that we could have. So right now, this is the maximum. His theory also says a minimum number. Okay? A minimum number would be 1. Okay? Now, how did I come up with 1? Well, remember, we're only talking about real roots here. If the roots are not real, then they have the potential to be imaginary. And what did we remember about imaginary roots? Those are conjugate pairs. They come in conjugate pairs. Okay? So remember, if the roots are not real roots are called imaginary. That's right, that's your I. All right, that's the I. Okay, so, and remember, imaginary roots come in conjugate pairs. Okay. So what this is saying is we have 3 positive real roots. I subtract out the potential 2 imaginary roots. That leaves us 1 more positive real roots. It has the potential to be positive. These are all just, the words are potential. Okay? So we counted backwards by 2 for the imaginary pairs. Okay? Possible pair of imaginary. Okay, that's why we counted backwards by 2. We count backwards by 2. So that takes care of your possible pair of imaginaries. All right, now he also goes on to say the potential number of negative real roots. Remember, if they're not positive, it doesn't mean they have to be negative. They could be imaginary. So what he says is all we have to do is swap out all the x's with a negative x. That's right. That's when we reflect over the y-axis, and we can do the counting again. So what we have to do here now to count, so the very, very first thing we have to do is we have to switch all the, so we have to replace all x's with a negative x. And then we have to clean up the, clean it up, simplify. And then we count. All right, so what does that look like? Here's my equation right here. I'm going to write it out here. And I'm going to write it out with the replacements. So it's 3 parentheses to the power of 4 minus 2 parentheses to the power of 3 minus parentheses squared. I'm running out of room, got to write smaller, plus parentheses minus, plus 3 parentheses minus 5. Ran out of room. All right, so here is a negative x, negative x, negative x, negative x. All right, start cleaning up. What happens with a negative x when you raise it to the power of 4? That's right, it's positive. So this stays 3x to the power of 4. All right, now notice here, negative x, when you cube it, is still negative, times that negative is positive. All right, negative x, when you square it, is positive, so now this is a negative. Stays negative here. And then positive 3 times a negative x is a negative 3x, and then minus 5. Okay, and now we count the sign changes. Well, again, remember there's a positive in front here. If you don't see a sign, it's positive. So it's positive, stays positive, and then it changes. And then it stays and stays. There was only one sign change. So this has a maximum of 1 negative real root. Okay? I cannot count backwards on 1. Okay? Because if I count backwards on 1, I subtract 2 from this, it gives me negative 1. It doesn't make any sense to say you have negative 1 root. Okay? So when we talk about our roots, we're only talking about whole numbers, no negative numbers. Okay? So, now, he also comes up with this potential number of imaginary roots. Okay? Now, in order to get the potential number of imaginary roots, this is what we have to do. Technically, it's the potential number, the maximum of imaginary. So this is what we have to do. First thing we have to do is we have to know how many roots are there altogether. That's right, there are 4 total roots. It's a 4th degree equation. So it's a little formula. So we need to know total roots. Then we have to subtract each of the mins. The minimum number of positive reals, and we have to subtract out the minimum number of negative reals. So the minimum number of positive reals was 1, and the minimum number of negative reals, I know it says max, but it's 1, so that's the maximum and the minimum is 1. And so 4 minus 1, we have a total of 2 imaginary roots. We have a maximum total of 2 imaginary roots. So you have the potential for 2 imaginary roots. Little theory here, this number better be even. If it's not even, you did something wrong. Why does it have to be even? That's right. All of your roots, remember your roots, your imaginary roots come in pairs. Okay, so it has to be an even number. All right, we're going to do a couple more examples of these. All right, example number 1. All right, so first thing we're going to do is you're going to have a bunch of questions to answer for me on your homework. There's actually 5 of them. The last one is to solve. Okay? So, state the maximum number of roots. Well, that's just your degree. It's a 3rd degree equation. We're going to have 3 roots. State the number of positive real roots. Under here I put max/min. So that allows us to do that counting backwards. So let's look here. That's right, it starts with a positive, and then it changes to a negative, and it never changes again. So there's only 1 positive real root. It has the potential to be 1 positive real root. Okay? This right here says nothing about negative, okay? And the thing is this, if they're not positive, you cannot say, oh, they're negative. No, that doesn't work, because they could be negatives, or they could be imaginary roots. So we cannot say that. So right now, the only thing that we know is we have 1 positive real root. You have the potential for 1 positive real root. All right, it says state the number of negative real roots. So that's when we have to do our sign change. That's when we have to swap out all the x's with negative x's. So cubed, squared. I'll fill them in. Remember, you swap out all the x's with a negative x. We have to clean it up. So negative x when you cube it is negative. Negative x squared is still negative. And then this is a positive, minus 2. All right, so how many sign changes do we have? Well, how many sign changes do we have? Well, it's negative, it starts negative, it stays negative, it changes, there's a change, count it out with your fingers, there's a change, and then we have another change. So we have 2 changes here. So 2 changes means we have a maximum of 2, and then don't forget, you got to count backwards now. And what do we count backwards by? That's right, we count backwards by 2. Why are we counting backwards by 2? Because that pair represents the possible imaginary roots. So right now what this is saying is you have a potential to have 2 negative real roots, 1 positive real root. Okay? We have the potential to have 1 positive root, 0 negative roots. But if I'm going to have 3 roots altogether, what's left over? That's right, we're going to have 2. All right, so let's figure that one out now. State the maximum number of imaginary roots. That's right, your little formula. It's the total roots minus each of the mins, minus the min positive, minus the min negative. Okay, so the total roots, there's 3. We had a minimum number of 1 positive root, or maximum because it was 1. And then the minimum negatives was 0. So that gives us a grand total of 2 possible, a maximum of 2 imaginary roots. Okay. All right. Let's do some solving now. So E, we're going to solve. Not hard. I did nice easy equation. Okay. Right. Your PQ list is just 2. So your P value is 2, which is factors are 1 and 2. Your Q value is 1. So you're just looking at a P over Q of plus and minus 1 and 2. Not a lot of choices there. All right. So I'm going to guess 2. So I have 1, -1, -2, negative, what did I do? 1, -1, -1, -2. I'm going to guess 2. Drop the 1. So it's 2, 1, 2, 1, 2, 0. There we go. We knew 2 works. Look at that. Look at that. Now look at 1, 1, 1. That's not factorable, so it could be real answers. So in other words, you could have like radical 3 underneath the radical, or else they could be a negative. But if we had a radical 3 underneath the radical, we could do a 1 plus radical 3 or a 1 minus radical 3. One's positive, one's negative, so it fits the real clauses here. Okay? All right, so actually, no, it wouldn't. All right, so never mind. So our A is 1, B is 1, C is 1. So I have -1 plus and minus the square root of 1 minus 4 times 1 times 1 all over 2. So that's right, -1 plus and minus square root of -3 all over 2. So we have -1 plus and minus I radical 3 all over 2. And we have our 2. Those are your roots. So notice, 1 positive real, and these ones are imaginary. So that means how many negatives did we have? That's right, we had no negatives. All right, one more. Just to keep that practicing that idea of how I'm asking the questions. All right, maximum number of roots, that's right, is 3. State the max min number of positive reals. All right, just remember, we're counting the sign changes. So positive to negative is 1 change. Back to positive is 2 changes. And then it stays positive. So it's 2 or 0. That's right, this is the max. This is the min. State the max number of negatives. Okay, then we got to do our swapping out. So negative x cubed minus times a negative x squared plus 15 times a negative x plus 17. Clean this up. That's negative. This stays negative because negative x squared is positive. Minus plus 17. How many sign changes? Count them. Starts negative, stays, changes. Only 1 change. There we go. 1 change. So that technically is the maximum and the minimum. That's both. So imaginary roots. That's right. It's your total roots. Total minus each of the mins. Min positive minus min negative. So we have 3 minus 0 minus 1, which gives us a grand total of 2. We have 2. All right, let's do some solving now. So again, nice and easy PQ list. P is 7, so E is solve. So P is 17. What are your factors of 17? 1 and 17. Q is 1. So your P over Q is plus and minus 1 in 17. Now let's try -1. Now the reason why I'm going start to -1 because I know there's only one negative root. If I can get -1 to work, then I'm all done. So 1, -1, 15, 17. So drop the 1, -1, -2. So it's 2, 17. Look at that, it works. Yay. So we have our one negative real root. That's not factorable, so I gotta do my quadratic formula. So it's 2 plus and minus the square root of, -2 squared minus 4 times 1 times 17 all over 2 times a 1. So 2 plus and minus the square root of a number all over 2. What's this? 4 times 17 is 68. -68 minus 4 is a -64. Oh, that's just plus and minus 8. So it's 2 plus and minus 8i all over 2. So we have 1 plus and minus 4i. So there you go. There's your one real root, and then these are imaginary. All right. Have fun with Descartes' rule of sign. Remember, he was a philosopher, so he could fill you with BS with all of his mathematics.